Hi, in this lecture we'll be discussing about one very important data science technique, what we call feature scaling. Let's imagine that we are given these 5 data points of several people. The features are their height in meter and their weight in kilogram. So first we want to plot these data points on a 2D Cartesian plane to see how they actually fit in a two-dimensional vector space. Okay. X-axis we want to plot their height, and in the y-axis we want to plot their weight. Okay. And we have drawn a grid representing our vector space, and we are going to plot our first data point. Okay, so the height in meter is 1.5, so the height values should be around here, but the problem is the y-axis values are so big that they are going out of the slide. Okay, so the data actually not fitting on these grid points. Okay, so what can we do? So one idea might be we have created a new column by dividing the weight by 25 and we got some new values. Okay, so now it looks like the data points are fitting within this graph, and here we have plotted those corresponding 5 points. Okay, so this is an example of feature scaling, a kind of manual effort. But this is not the standard way the ML practitioners follow, because imagine that we are learning a logistic regression or a linear regression model. What happens? Still, the weight are actually in the scale of twice than the height. Okay, so if we use our data in this way, then some of the models will struggle. So what are the other ways? So another simple way is that we divide these values, both height and weight, by their maximum value. Okay, so if you do that, then what will happen? All the data points will actually come within the first square area that is bounded by 0 and 1. Okay, so you can see that these values, both the height and weight, when you divide by the corresponding max values, the value actually came within the range of 0 and 1. So this is one standard practice. So for a little explanation here, the circle centers are the data point locations. The scales of the circles are only for the visualization purposes. So all these data points actually move to this location, the same data point. Okay. So this is a standard way of data scaling or feature scaling. And this is the well-known min-max scalar. The formal equation is your scaled x is actually x minus minimum x divided by max x minus minimum x. So if the minimum value is 0, then it becomes you divide each feature by its max value. You are also allowed to put any mean value here. For example, here we scaled values between 0 and 1, but you can choose any value as your minimum value, but it needs to be actually less than the max value. That's the idea. Okay, so this is the popular min-max scalar. Another popular scalar is standard scalar. And here the whole idea is your new value will be your original value minus the mean of the corresponding column value divided by the standard deviation of the column value. Okay, so what are their properties? Here scale values are centered across the 0 axis. Okay, so here all the values will be coming around here. This is a popular data scaling method practiced by the neural network community.